On this next example, we can't do anything to factor the denominator. However, we should factor the numerator. Since that's a 1x squared, we just need two numbers whose product is -6 and add up to +1. So the quantity x plus 3 times the quantity x minus 2 will do the job. There won't be any reducing, so there won't be any wholes. That wouldn't change the domain anyway, because you're supposed to take the denominator in its factored form before any reducing. Once you've got that x is not equal to 6, put the x bar for x is a real number such that x is not equal to 6, and put the curly Q braces around it. Switch that not equal to an equal sign, and we've got the equation of only one vertical asymptote. Now, before the factored form, we had a degree of the numerator 2 greater than the degree of the denominator 1. That tells us that the other type of asymptote we're going to see is linear, because the degree of the numerator is 1 higher. To find out the equation of it, we could either do long division of polynomials, numerator divided by denominator, or since that's a linear divisor and 6 makes 6 0, we could use synthetic division. Multiply, add, multiply, and add. What this is telling us is when x is not equal to 6, then r of x is actually also equal to x plus 7 plus the remainder of 36 over the divisor. So what's going to happen when x is large absolute value, then x minus 6 will also be large in absolute value. Could be positive, could be negative, doesn't matter. So when you divide 36 by numbers with larger and larger absolute values, that's going to head off towards 0, leaving us that the function at the extreme left and extreme right is going to be acting closer and closer to the line x plus 7. Now, before graphing, we should also find out other special values of x for x-intercepts. Since there was no reducing, with x equaling -3 and x equaling 2 being the zeros of the numerator, but not of the denominator, then -3, 0, and 2, 0, those are going to be x-intercepts. And if we put in 0 for x, either in the original or in the factored form, you're going to have -6 over -6, which is just 1. So 0, 1 is the y-intercept. Our only special values of x are -3, 2, and 6. In between the -3 and the 2 is the 0, which gave us the y-intercept. So we want to know what's happening between 2 and 6, as well as left of -3 and right of +6. So let's plug in -4 over here and 7 here. And it would be nicer to, instead of having to square something, use the factored form. So let's see, we had x plus 3 times x minus 2 all over x minus 6. All right, when we put in -4, it's going to be -1 times -6 over -10. So -6/10, which reduces -3/5. We've already got in between -3 and 2. Let's put in between 2 and 6. Let's put in 3. It's going to give us the first factor of the numerator is 6. Second is 1. And in the denominator, -3. So that's going to give us -2. And then 7. 7 plus 3 is 10. 7 minus 2 is 5. And 7 minus 6 is 1. So pretty large value there, 7,50. Now, before plotting those points and connecting, I want you to notice that after the factoring, each of those factors was to the first power. So for these x-intercepts, we're going to see the x-axis being crossed, the y values to either side close by will be changing sign between positive to negative or negative to positive. And similarly, because this is only degree 1, which is odd, close by the vertical asymptote x equals 6, we'll also see a change in signs. So we're plotting -4, -3/5, -3, 0, 0, 1. There's that change in signs. We'll see the x-axis being crossed. 2, 0, 3, -2. Again, a change in signs. We'll see the x-axis being crossed at 2, 0. We'll show the vertical asymptote x equals 6. And then 750, here's another change in signs of the y value. You can't cross the vertical axis, but we still get that change in signs for the y coordinates. And then we're also going to graph y equals x plus 7 for the slant asymptotes. So here we go. Our -4, -3/5, 3, 0, 0, 1. What else? 2, 0, 3, -2, and 750. We can't see that right now, but I'll change the window. We would have never known to do that if it weren't for our analysis. There's the slant asymptote. All we would see in a regular viewing window is this portion. But if we zoom this out so that we can see the 7,50, now we see the other point, and we can figure out that this is going to be this portion up here is going to be trapped between the vertical asymptote and the horizontal asymptote. Sorry, the vertical asymptote and the slant asymptote.